Assalamualaikum and good morning. My name is Muhammad Kabir Ruslan. We are from group number 4. Let's start with the introduction. First of all, our product is called multi-stage grease trap. So, what is grease trap? Grease trap is a device that collects and reduces the amount of fats, oils, and grease that enter to the main sewers. Okay, so our objective for this project is to develop a prototype and solve FOG problems using cathode fiber. What is FOG? FOG is a short form for F, fat, O, oil, and G, grease. For our scope of study, we focus on develop a prototype of the grease trap by finding suitable design to create a good and efficient grease trap as a filtering system by doing a lot of research on internet about what their problem and what their need, what their hope, and what they usually do. Next is significance of the project. So what is the problem that makes us want to make this product? First, grease and fat reforms on the interior of pipes and other surfaces that cause pipe clog. Secondly, for your information, restaurants and food processing industry are the main source of greasy waste that can cause water waste pollution. Third is grease emits an unpleasant and uncomfortable smells, or we can call it bad smells. Now, we will discuss about identification of need. What my observation in this project, I see to make a good grease trap, we have to care about our city. We have to be concerned about the treatment given by city center and the manpower used in clearing blockage near the target restaurant. Next, we must know the size, the capacity, and the flow rate that needs to be used. Third, we need to know where we want to place the grease trap. And finally, we must know what maintenance is needed, how to clean, and how to repair the grease trap if damaged or does not work properly.
Hi, my name is Taufik Hidayat Muhammad Rasul, number matric AA191989.
Now let's move on background research. As you can see, there are three types of grease trap: hydro-mechanical grease trap, gravity grease trap, and automatic grease trap. First is the hydro-mechanical grease trap. This type of system depends on heat and gravity to separate water from FOG. It is usually made of carbon or steel. Water flow is controlled and hot water is allowed to cool. Next, grease and fat will sink and later, this FOG will be trapped in the oil trap that has been prepared. The lags in this product is it must be cleaned manually and regularly. The second one is gravity grease trap. Generally, this type of system depends on gravity. The size of this grease trap is much larger than hydro-mechanical one, and it does more effective than hydro-mechanical grease trap. FOG has a higher density than water, so it will float. All we have to do is just clean up the floating waste. And our third one is automatic grease trap. This type of grease trap will clean automatically. It will need electricity or batteries. And yeah, this type of grease trap is the most efficient than other type, but it costs a lot and very expensive. And now we would like to introduce you about carbon fiber. We will use this material in our product. Carbon fiber is the perfect solution for the oil leak problem. Why? Because this material will not absorb water. It have a significant hydrophobic aspect that make this material can absorb oil and can be used as the oil absorbent. Hydrophobic maksud dia fear of water, ketakutan terhadap air. In conclusion, carpet fiber is a natural oil absorber that has a very high stand in the economy and environmental aspect.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Izzat Haris bin Muhammad Makran. Matrix number AA192054. So I'll start with this embodiment design. So first we get into the flowchart. So to start with this journey of our final year project, we first discuss the direction of the project with our supervisor, Encik Tuan Muhammad Hafiz bin Tuan Ibrahim. Next, literature review. We start doing research about background projects, objective and problem statements to make this project work. And then conceptual design, we also came up with 3 conceptual design, and finally we have decided with our final design, which I will show you on the next slide. Lastly, we finish our final report on the 21st of January 2021, and now we are here presenting to you. So next is the final design. This is our initial sketch that I do by myself, and then we have this final design that I constructed using SolidWorks. I constructed by part and assembly it. And then next is exploited view. We have from number 1, we go anti-clockwise. Starting from number 1 is stainless steel grease trap body. Number 2, stainless steel lid. 3, pipe elbow. 4, pipe T for the first chamber. 5, pipe T for the second chamber. Number 6, L pipe connectors. Number 7, filter connector. Number 8, carpet fiber filter. And lastly, pipe T N. So, and then we go to the carpet fiber. As you can see, this is the highlight of our part for our kitchen trap design, which is on the left side is the loft filter connector, and on the right side is carpet fiber filter. So the function of the loft connector on the left side is basically to let the water flow through it, and it increase the diameter of the inner tube so that the water can flow smooth and evenly. So next, on the right side, we have this carpet fiber filter. As you can see, there are a few small holes on the both sides, and we will put the carpet fiber in between the space so that it will filter the water that flows through it.
Hello, my name is Muhammad Imran bin Osman, matrix number AA190056. So now I will be talking about the material selection. First, for the body, we chose stainless steel. Why? Because it is corrosion resistant, high strength and durability. It's highly machinable and workable to create complex shapes. Machining services are available without special equipment, easy to clean with household products such as detergents, and it's worth the money in the long run. For the pipes, we chose PVC. Why? Because it's a man-made plastic that prevents oxidation. It's highly durable, not a toxic substance, and it is easily cut, glued, and fitted. For our design specification, we chose, for the size, we chose 3 by 300 width by 300 height and 600 length in millimeters. Our flow rate is 90 liters per minute, and our capacity is 68 liters. The stage 1 size is 200 length by 300 width by 300 height in millimeter. Our stage 2 size is 250 length by 300 width by 300 height in millimeters, and our stage 3 size is 200 length by 300 width and 300 height in millimeters. Our materials are stainless steel and PVC. Next, I'll talk about how it works. So in stage 1, the water will flow into the grease trap from the intake pipe and into the chamber, where fat, oil and grease will flow to the top of the chamber and water will flow down. In stage 2, the same process occurs in stage 1. The water will then flow to the last chamber. Stage 3, here the last few bits of fat, oil and grease is filtered to the outtake pipe through the carpet fiber filter. The clean filtered water then goes down to the drain or sewage system. Our recommended maintenance method is clearing the solid or food waste into a plastic bag, or scoop or pump the oil into the container. Our conclusion is we have simply introduced our multi-stage grease trap designed to solve the problems faced by the restaurant and help out the environment. With this filter, we hope restaurants that have a weak or no filtering system will use this filter and enjoy a cleaner environment. Without an oil trap, the fat, oil and grease will continue to enter the water catchment area, and we will have a hard time repairing it. As the saying goes, prevention is better than cure.